10th plus 2 வில் ஒவ்வொரு ஆண்டும் தொடர்ந்து மாநில அளவில் பல சாதனைகளை புரிந்து வரும் நாமக்கல் குறிஞ்சி கல்வி நிறுவனங்களில் CBSE பாடத்திட்டத்தில் சீனியர் செகண்டரி பள்ளியாக தரம் உயர்த்தப்பட்டு IIT நீட் தேர்வுகளுக்கு பல வெற்றியாளர்களை உருவாக்கிய ஆசிரியர்களை முழு நேர ஆசிரியர்களாக பணியமர்த்தப்பட்டு தினம்தோறும் வகுப்புகள் நடைபெறும்.
குறிஞ்சி எஜுகேஷனல் இன்ஸ்டிடியூஷன் காவேட்டிப்பட்டி நாமக்கல். Admission in progress. CBSE KG to 12 contact 9025895176. Metric 6 to 12 contact 9344567484. For online admission log on to www.kurinjischoolnkl.in.
Good morning students. Today we are going to discuss another important terms from coordination compounds. Already in my previous session 6 important terms already completed. The first one is central metal atom, second one is ligands. Already types of ligands and classification of ligands also completed in my previous session. And third one complex ion, fourth one is coordination and ionic sphere, and fifth one coordination sphere, ionic sphere, and coordination polyhedron, and cationic, anionic and neutral complexes. These are already completed in my previous session. Now today we are going to discuss remaining important terms in coordination chemistry. So seventh term is coordination number. This is the most important term in coordination compound. This term is frequently coming in all kind of the exams. So given compound, what is the coordination number? That kind of the questions are frequently coming in the different type of competitive entrance and also board exam. So what is the exact definitions of the coordination number? See here, the maximum number of ligand, listen carefully every student, the maximum number of ligand which can be coordinated to a central metal atom or ion is known as coordination number of the central atom. Coordination number is nothing but coordination number is always represented the central atom. But what is the exactly definition of the coordination number? If how many ligands attaches to the central metal atom, the number of the ligands are represented as the coordination number. For example, you know that very well, ligands always directly attaches to the central metal atom. Appo how many ligands attaches to the central metal atom, that number is coordination number of the central metal atom. Coordination number of the central metal atom. So see here once again, what is the coordination number? The maximum number of ligands which can be coordinated to a central atom or central ion is known as coordination number of the central atom. Here KNOWN N letter is missed. So it's known as coordination number or coordination number of the central atom. Okay, Anna? That is a coordination number. Now see here example, potassium ferrocyanate, the best example, potassium ferrocyanate. The formula of potassium ferrocyanate, K4FeCN6, K4FeCN6. See, already inside of the square bracket, Cn, it is a ligand, already ligands are present in inside of the parenthesis, you know that very well. So how many ligands are there here? 6 ligands are there. So that's why now the coordination number of central metal atom, which is a central metal atom here, iron is a central metal atom. So how many ligands are directly attached to the iron here? 6 ligands are directly attached to the central metal atom. That's why iron coordination number is a 6. Iron coordination number is a 6 because of the 6 ligands are present in this molecule. So see here, 6 Cn ligands are coordinated to the central Fe+2 ion. Therefore, the coordination number of the ion is iron. The coordination number of the iron is 6. Okay, now one more example. CuNH3 takes 4 sulfate, SO4. Here, what are the coordination number? This is a central metal atom and this is a ligand. 4 ligands are directly attached to the copper. 4 ligands are directly attached to the copper. Hence, the coordination number of the copper here 4. Coordination number of the copper here 4. So this is the coordination number. Once again, the maximum number of the ligands which can be coordinated to a central atom or ion is known as the coordination number of the central atom or ion. Central atom or ion. In potassium ferrocyanide, coordination number is 6, and copper ammonium sulfate coordination number is the 4th. Next, some important point regarding to coordination number. Coordination number of metal vary from 2 to 10. Actually, if you observe all different type of the coordination compound, generally the coordination number start with 2 to 10. Mostly 2 coordination numbers are there, 3 coordination numbers are there, 4, 5, 6, 7, 8, 9, 10. So here coordination number of the metal vary from 2 to 10. But the most common coordination number, underline this point my dear student, the most common coordination number in coordination compound, it means most of the compounds show 4 or 6. Either 4 coordination number or 6. That is the most important. But generally coordination number of the any metal can be show 2 to 10. General number 2 to 10. But most of the coordination numbers in a coordination compounds are 4 and 6. So most important point. Next point, the coordination number of a metal ion depends on mainly its nature. It's a nature. So the coordination number, it's mostly depending on the nature of the compound. Nature of the compound. This is also another important part. And one more important point, the coordination number may be influenced by temperature and pressure and the nature of the solvent. Temperature, pressure and nature of the solvent is also decided by the coordination number. Now see here, the most common coordination numbers are 4 and 6. Keep it in your mind. A particular metal in a different compound, different metal ions are there or metal atoms are there. Especially here see, a particular metal may be exhibit different coordination number in the different complexes. So, one metal ion is not always show same number of the coordination number. It changes from compound to compound. It is a changes from compound to compound. So that is the most important point. Any metal cannot exist at same number of the coordination number. It's different from compound to compound. For example, see here, platinum coordination number 4, where platinum tetrachloride. Here in the platinum tetrachloride, 4 ligands are there. Chlorine is a 4 ligands. So that's why platinum coordination number right now here 4. Aprama, Kila one more example is there. Platinum coordination number is 6, where in platinum hexachloride. So platinum hexachloride, the platinum coordination number is 6, and platinum tetrachloride, platinum coordination number is a 4. That is the most important point. The metal cannot show same kind of coordination number in a coordination compound. It maybe changes from complex to complex. Okay, Nana? This is the second important point about coordination number. And third important point, see here, the geometry of complexes. Generally, coordination compound has different type of the geometries are there. That is nothing but polyhedron structures. So, the geometry of a complexes depends upon the coordination number. That is the most important point, my dear student. Generally, the geometry of the complexes, either square pyramidal, octahedral structure or tetrahedral manner. So the geometry of the complexes means coordination compound. The geometry of a complexes, it's depending on the coordination number. So coordination number only to decide the geometry. For example, if 6 is there, octahedral manner. For example, central atom here are 1, 2, 3, 4, 5, 6. So coordination number only to decide the geometry of the complexes of it is a central atom. You see here, central atom which coordination number 6. See na? The central atom with coordination number is a 6 usually form octahedral complexes. Underline this one. If any one of the compounds show coordination number is a 6, obviously that complex show octahedral structure or octahedral geometry. Aparma, coordination is 4 because of already I told very clearly the common coordination numbers are 4 and 6. If any one of the complexes shows 6 means octahedral complexes, and any one of the compound show coordination number is a 4, tetrahedral manner or square planar. Tetrahedral manner or square planar. These are the most important points regarding to the coordination number. Once again, Nana, what is the coordination number? The maximum number of the ligands which can be coordinated to a central atom or ion is known as the coordination number. Then generally the coordination number vary from 2 to 10, but most of the common coordination numbers are 4 and 6. 4 and 6. And one more important point, one metal atom is not always to show same number of the coordination number. It's a differ from the compound to compound. For example, a platinum tetrachloride, platinum show coordination number is a 4. Appo structure another tetrahedral structure. Appo platinum hexachloride, the coordination number 6. Appo in the platinum show the 6 coordination number and the structure is the octahedral structure. Then one more important point, the geometry of the coordination complexes or geometry of the coordination compound, it's depending on the coordination number. If 6 is there, it's the octahedral manner, and 4 is there, tetrahedral manner or square planar. These are the coordination number, and the 2 marks point of view, the definition and information regarding to coordination number is the most important. Could define coordination number or explain the coordination number, that such kind of the questions are frequently coming in the board exams. Okay, Nana? Next, 8th term in coordination chemistry, oxidation number. Most important, Nana, oxidation number or oxidation state of the central metal atom. Oxidation number and oxidation state of the central metal atom. Already you know that very well how to calculate oxidation number or oxidation state on the central metal atom. We are already studied in the 11th standard redox reactions chapter. So the same rules is also applicable right now in this concept also. Whenever you calculated oxidation state or oxidation number of the any central metal atom, the same rules are applicable right here also. What are the rules are followed in the 11th standard redox reaction? So the same rules also applicable in this concept also. So what is the oxidation number and what is the oxidation state of the central metal atom? Now see here, the number which represents the electrical charge which the central atom is called oxidation number. இப்போ ஒரு central metal atom ஒரு particular electrical charge number is there. In a central metal atom, one particular electrical charge number is there. That number is generally called oxidation number. That number is generally called oxidation number. You know that very well, already I said very clearly. The oxidation number or oxidation state of the central metal atom may be calculated according to the common rules and regulations. Already you are studying. So here, what is the exact oxidation state and oxidation number? The number which represents the electrical charge which the central atom, it is called oxidation number and oxidation state of the central atom. Now see here, one example is there, potassium ferrocyanide. So what is the oxidation number of iron? What is the oxidation number of iron in potassium ferrocyanide? Already you know that very well, rules and regulations of whenever you calculate oxidation states. Now see here, first of all your target you can calculate iron oxidation state, that is represented as a X. So unknown. Now we will target, you will calculate iron oxidation state, that's why you put X there. Apparama, potassium is a first year group element. Yes, potassium is a first year group element. So the oxidation state of first year group elements obviously +1. How many potassiums are there here? 4 into +1. Okay na? So potassium 4 into +1 plus, now we will target is calculated iron oxidation state, that value is X plus cyanide, Cn. Cyanide oxidation state is a -1. Most important, Nana. Cyanide oxidation state is a -1. How many cyanides are there here? 6 cyanides are there. Appo 6 into -1 is equal to 0. So why this called is equal to 0? This is a neutral complex compound. There is a net charge. So that's why the individual, listen carefully, the individual atom of the oxidation number is equal to 0. In a neutral molecule. It is a neutral molecule. That's why the individual oxidation states of the atom is equal to 0. So here potassiums are 4 is there. 4 into +1 because of the each potassium carry +1 oxidation state. And now your target to calculate iron. So that's X plus how many cyanides or nothing but how many ligands are there? Here 6 ligands are there. So total charge is equal to 0. Net charge is equal to 0. Now my question right now, my dear student here, how many ligands are there here? 6 ligands are there. The 6 ligands means the coordination number of the iron is the 6. Okay na? The coordination number of iron is the 6. So now here see 4 into +1 plus X plus 6 minus 1 is equal to 0. Hence 4 plus X minus 6 is equal to 0. X is equal to +2. The oxidation state or oxidation number of the iron, central metal ion, is equal to +2. Here +2. You know that how to calculate oxidation state? The same concept already you studied in 11th standard redox reaction. The same rules and regulations also applicable in this concept. Okay, Nana? Now in potassium ferrocyanide, my question, Nana, in potassium ferrocyanide, central atom oxidation state +2, central atom coordination number is 6. How? Because of 6 ligands are there. So central atom oxidation state +2, central atom coordination number is a 6. If the coordination number 6 means, what is the geometry here? Octahedral complex. Already clearly explained. If coordination number 6 octahedral, if coordination number is a 4 is a tetrahedral. So the coordination number is always decided to the structure of the complex compound. Next, second example. Now see here second example. Coordination number of copper in a copper ammonium sulfate. Coordination number of a copper in a copper ammonium sulfate. Same rules and regulations are applicable here also. Now see CuNH3 taken 4 times. So now what is the coordination number of copper? 4, because 4 ligands are there here. Then now we will target you calculate copper, that is expressed in the X plus ammonia NH3, entire the ammonia oxidation state is 0. So 4 into 0 minus sulfate oxidation state is -2. That's why I represented here very clearly. NH3 oxidation state, net oxidation state 0, sulfate oxidation state is -2. Sulfate oxidation state, enter the SO4 oxidation state is a -2. Why here NH3 is 0? Because of nitrogen -3, 3 hydrogen +3. -3 plus 3 get cancelled. The net charge is equal to 0. Clear, ma? So once again see, nitrogen -3 because of 3 electrons are accepted. Apparama hydrogen, each hydrogen +1. Appo etine hydrogen irukira? 3 hydrogen. So -3 plus 3 get cancelled. So total net charge is equal to 0. Similarly here oxygen, each oxygen -2 into 4 -8. So here -8 apramanda +6. Sulfur is a +6. So -8 plus 6 means -2. How to calculate net charge? This is the process now. So now what is the copper oxidation state right now here? Copper oxidation state is a +2. So in copper ammonium sulfate, copper oxidation state is a +2. Apparama coordination number of the copper here 4. Next, third example. Oxidation number of iron, gold and nickel in the following compound. FeCN6 3 minus, HeAuCl4, nickel carbonyl. Three examples are there. Three examples are there here. And FeCN6 3 minus, NiCO4, nickel carbonyl, hydrogen tetrachloride. Now see here, FeCN6. Now we will target here Fe, X plus 6 are cyanide, 0, minus 1, cyanide is a minus 1, Cn minus 1 is equal to net charges are there here. Net charge, what is the net charge here? 3 minus is equal to minus 3. So after that the X value is equal to plus 3. So if Fe iron cyanide, iron oxidation state is a plus 3 and coordination number is a 6. Next in this example say hydrogen oxidation state plus 1 plus your target R X plus 4 into chlorine. Each chlorine has minus 1. So total X value is plus 3. Here R oxidation state is a plus 3. Rm oxidation state is a plus 3. Next nickel carbonyl. Nickel most important is the neutral complexes. So here what happened? Now your target is nickel. N X value. Nickel value is X plus 4 into CO. Most important one is a CO. Carbon monoxide net oxidation state is a 0. Carbon monoxide net oxidation state is a 0. Upon NiH X plus 4 into 0 is equal to 0. The total oxidation state of the nickel in this nickel carbonyl is 0. Okay now, that is the most important neutral complexes nana. There is no any oxidation state on the nickel in nickel carbonyl. So see here nickel X plus 4 into 0 is equal to 0. Therefore X is equal to 0 right now here. Okay, in a nickel carbonyl, nickel oxidation state is a 0. In Rm plus 3 and iron plus 3. Okay, Nana? These are the oxidation states of the compound. You know that how to calculate the oxidation state. And the last and final term, charge number of a complex ion. Entire the charge. So this is a complex ion, completely complex ion. The total charge, this is a complex ion charges. So see here, the net charge carried by a complex ion is called charge number. This is the charge number. The net charge carried by a complex ion is called charge number. It is equal to the algebraic sum of the charge carried by the central atom. So most important point, what is the central atom oxidation state? That is a charge number of complex ion, almost similar. That's why here see, the net charge carried by a complex ion is called charge number. It is equal to the algebraic sum of the charge carried by the central atom and ligand attracted to it. Now see here, FeCN6 4 minus. Ipo FeCN6 4 minus, what is the oxidation state of the iron here? Now see how to calculate the charge number of the complex ion. Fe, actually Fe already you know calculated here. So plus 2 and 6 into minus 1, net charge is a minus 4. Net charge is a minus 4. Okay ma? These are the first 9 important terms in coordination compounds. Okay, so all coordination compound terms are very important. So what are the terms are there? Central metal atom, ligands, complex ions and coordination sphere and ionic sphere and coordination polyhedron and coordination number and charge number of the complex ion and oxidation number. Now the general representation of the coordination compound. Generally it is represented like this: MLN plus or minus X. M is nothing but central metal atom, L is nothing but ligand, N is nothing but coordination number, plus or minus X is represented total net charge. For example, now see here, M is nothing but central metal atom, L is nothing but ligand, N is nothing but coordination number, plus or minus is a net charge, X is represented value, integer value. Now here CONH36 taken Cl3. Here CO is a central atom, cobalt, And ammonia, NH3, is a ligand, 6 is a coordination number, and square bracket is a coordination sphere. Already I said, outside of the square bracket, it's a counter ion or ionic sphere. So these are the terms of the coordination compound. Okay, Nana? In this session, I successfully completed last my 4 classes. I successfully completed the entire coordination compounds important terms. In my next class, I will go to discuss the nomenclature of the coordination compound. So you don't know the meaning of these terms, definitely you will face problem in the upcoming concept. So every student compulsory to learn all terms. Okay, Nana?